Hi everyone. In this lecture, we will see the list data structure in Python. In the last lecture, we have seen the string data structure, which is an immutable sequence of characters. Now we are seeing list. List are what? They are mutable sequence of items. They can contain any type of items inside them. Okay. So let us start. Let's see what lists are and what are the operations on lists. Firstly, introduction to list. A list in Python is an ordered, mutable, heterogeneous collection of items. So it is a collection of items, like you can have a group of items basically, and it has certain properties. So what are the properties? First is it is ordered. Ordered means it will have an order. It will like you can define like this is the first element, this is the second element, and so on. So every element will have an index or a position. So elements are stored in a definite sequence. So they will have a sequence. Second is mutable. So strings were immutable. You cannot change a string once created at the same memory location. You have to create another string. But lists are mutable at the same memory location. You can change the elements of a list, or you can add elements, you can delete elements, anything. You can do like, you can change the list basically at the same memory location. So they are mutable. You can change, add or remove elements inside a list. Then it is heterogeneous. Heterogeneous means they can contain different data types in the same list. So in a single list, you can have an integer, a floating point number, a complex number, a string, and a list itself. You can have a list inside a list or a tuple, dictionary, anything. Any data type can be present inside a list, and different data types can be present in the same list as well. And this is different from other languages. For example, in C++ and Java, we have arrays, and the equivalent of arrays in Python is list. And arrays are homogeneous. They can contain only same type of items. So in C++, if we create an array of integers, it will only contain integers only. You cannot have a floating point number then. But in Python, in the same list, you can have different type of items as well. And then they are indexed, which means elements can be accessed by position or the index, which is starting from 0. So you can actually access any element of a list or change it using its index. Okay. So firstly, how do we create list? Lists in Python are created using the square brackets. So in the square brackets, if you write elements which are comma separated, so you just have to write comma in between them, and this is how you can create a list, and you can store it in any variable like this. So if you just create an empty list using square brackets, you can do it this way. You have not written anything inside the square brackets. This will create an empty list, which means a list with size 0. It does not contain any elements. Okay. So you can create an empty list like this. So here empty is the variable. When you print it, empty list will be displayed on the screen. And you can have a list with same type of elements. For example, here we have 3 integers. So numbers is a list containing 1, 2 and 3. So numbers is a list like this. And when you print the type of numbers, or even if you print the type of empty, you will get the output as class list like this, which means it is of list data type. So the data type will be list. And you can contain, a list can contain heterogeneous elements, which means different type of elements as well. So here mixed list contains a integer and a string and a floating point number and a boolean value. So different data types are present, and this is allowed. So in this mixed list, you will have one at the 0th index. So the index will be 0. This string will have index 1. This floating point number will have index 2. And this boolean value will have index 3, right? So you can have different or heterogeneous data types in the same list as well. So this is how you can create list using the square brackets. Another way of creating list in Python is using the list constructor. So we don't understand the meaning of the word constructor right now. It is like this we will cover in classes and objects. Since I told you like any data type in Python is a class. That is why when we print the type of a variable, class word is there, class list, class str and so on. So any data type is a class. Internally it is implemented using a class. And classes have a property, like they have a function called constructor. So similarly, like here list will also have a constructor, but you don't need to understand it right now. For now, you can consider list as a function only, okay? So Python provides a built-in function called list function. And inside the list function, if you pass any iterable, you can pass any iterable and it will convert that iterable into a list. So Python provides a built-in function list that creates a new list from an iterable. So the syntax is list, and inside the list you can pass any iterable. For example, if I say list and let's say I pass the iterable string ABC in it, what will happen? String is an iterable, and in that iterable we can access every character of the string one by one. So it will give every character one by one. So it will create a list containing the elements A and then B and then C. So this list will contain 3 strings A, B and C like this. And that is how you can pass any iterable inside the list constructor or the list function. And if you do not provide anything, if you do not provide any argument inside the list function, it will create an empty list. So here empty is equal to list and you have not passed anything. So empty variable will contain the empty list. When you print empty, empty list will be displayed. So if no argument is provided, it returns an empty list. Let us see some examples. So first we have a string, s is equal to the string gate, and the characters, like we created another variable chars, which is list of s. List of s. Now s is a variable containing the string gate, gate. This is a string. S is a string and string is an iterable which will give one by one every of its characters in the sequence. So it will create a list containing the elements G, then A, then T, then E like this. So this list will contain 4 elements at indices 0, 1, 2 and 3. So when you print this list, you will get the list G, A, T, E in the output. Okay. Now you can pass any other iterable as well. For example, range function is also an iterable. List itself is an iterable, tuple is an iterable, any iterable you can give. So you can give the range function as well. So if we give range 1, 5, what will happen? Range 1, 5 takes what values? So here starting point is 1, stopping point is 5, and by default the step size is 1. So the range function will give you 1, 2, 3 and 4. This range function will take values 1, then 2, then 3, then 4. 5 will not be there because its stopping point is exclusive. So when you convert this into list like this, it will give you, it will convert this iterable into a list like this. So the list will contain 4 elements 1, 2, 3 and 4. So if you convert a range function into a list, when you print the list, it will have the output 1, 2, 3, 4 like this. So you can pass the variable here or the range function itself as well. Anything is fine. Okay, so you can pass any iterable basically. So this is how you can create lists using the list constructor or the list function in Python. Now accessing elements, accessing any element is exactly same as strings. Indexing, like the positive indexing, negative indexing for list works exactly same as strings, because that is also a sequence of elements. String is a sequence of characters, list is a sequence of elements. Indexing works exactly the same way. So indexing in Python allows us to access individual elements of a list using their position or the index. Positive indexing starts from 0 and goes to length of list minus 1. Right? Positive indexing goes from 0 to length of the list minus 1, which is left to right traversal. And the negative indexing starts from minus 1 and goes backwards up to minus of length of list, right to left traversal. So here we will traverse right to left. So let us say there is a list containing 4 elements, 10, 20, 30 and 40. Then the positive indices for these elements will be 0, 1, 2 and 3, and negative indices will be minus 1, minus 2, minus 3 and minus 4. Here the length of this list is 4. So positive indices go from 0 to length minus 1 and negative indices go from minus 1 to minus of length of string like this. Okay. Now if you want to access elements, you can do that using the indexing inside the square brackets. So if you have a list, again the elements are 10, 20, 30 and 40. Then the positive indices will be 0, 1, 2 and 3, and the negative indices will be minus 1, minus 2, minus 3 and minus 4. So when you print list of 0, then 0th element, which is 10, will be printed. List of 1, then first element, which is 20, will be printed. List of minus 1, which means the last element, which is 40, will be printed, and list of minus 2 means second last element, which is 30, will be printed. So the output will be 10, 20, 40 and 30. So this is how you can access a particular element inside a list in Python, and it can contain heterogeneous items as well. So if let's say there is a list containing elements, first is a string hello, then second is another list containing elements 1, 2, then third is a floating point number 3.14, then fourth is the boolean value false, Then here this list contains 4 elements. You will see comma, but here there is another comma, but this is another list, right? So this entire list is a single element. So here you will have this as the first element, this is the 0, 1, 2 and 3, or -1, -2, -3 and -4. So if you print A of 1, A of 1 means this entire element. This entire element is itself a list. So you will get the list containing elements 1 and 2. If you print A of 2, you will get the floating point number 3.14. If you print A of 0, you will get the string hello. Like this. Okay. So it can contain heterogeneous elements as well, and the indexing will work the same way. Now list mutability. So strings in Python are immutable, which means in place or at the same memory address, you cannot change elements of or the characters of a string. But lists are mutable. You can change the elements of the list at the same memory location. Lists are mutable, meaning once created, they can be changed. So if you have a list, let's say again, containing elements 1, 2, 3. So in memory 1, 2, 3 list will be stored, let's say at memory location 756, and the variable A will be pointing to it. Now you can actually say that so indices are 0, 1 and 2. So you can say the A of 1 is 100. That is allowed. You can just change an element at the same memory location. Or you can even say A of 2 is now the string hello. So this is also allowed. You can change this element to string hello. Or you can add an element if you want. You can do that. Or you can remove an element if you want. Anything is possible. How to add an element, how to remove an element, we will see. But any type of operation is allowed and it is mutable. It can be changed. So you can modify an element in place or at the same memory location. So let's say the list contains elements 1, 2, 3. Now you say list of 0 is 100. So the indices are 0, 1 and 2. So list of 0 is 100 means what? 0th element will change to 100. So this element will change to 100 now. So the elements now present in the list are 100, 2, 3. So if you print list after this operation, the output will be 100, 2, 3. Okay. And that is how lists are mutable. Now slicing in Python, we have already seen this concept in strings. The same concept can be applied to any sequence, which means list or tuple as well. So slicing is the process of extracting a portion of the sequence, and it has the syntax sequence start, stop, step. And you have 2 colons, and there are 2 possible syntaxes. If you have 1 colon, you are only giving start and stop, and step will be taken as 1 default value. And if you are using 2 colons, you are giving start, stop and step all 3. So start is the index to begin slicing from. It is inclusive and default is 0. Stop is the index to stop slicing at. It is exclusive and it defaults to the length of the sequence. And step size or interval is optional. You can skip it as well. It defaults to 1. So if you don't understand this, you can watch the string lecture. There I have covered it in detail. Okay, same concept will apply to list as well. So in the string lecture, we have seen accessing elements and slicing in detail and solved a lot of examples. So exactly same theory will be applicable to a list as well, because there you had character, here you can have elements of any type, that's all. Okay, so let's see an example. Here the list contains this elements 0, 1, 2, 3, 4 and 5. So the indices are 0, 1, 2, 3, 4 and 5. And the length of the string is 6. So if you print list 1, 4, here 1 is the value of start, 4 is the value of stop, and step size is not given, so default value, which is 1, will be taken. Step is 1, which means you will do left to right traversal. Start is 1, which means you will start at 1. Stop is 4, which means you will stop at 4. And 4 is exclusive, so you will stop at 3. So this slice will be taken and it will give you another list. It will give you another list containing elements 1, 2 and 3. This will be the slice. So if you print list 1, 4, another list containing elements 1, 2, 3 will be printed. Similarly, list 3 will do what? If you have list 3, so here step size is not given, so step size will be taken as 1. Stop is given as 3. Start is not given, so default value of start, which is 0, will be taken. So from 0 you will go till 3. 3 is not inclusive, so you will go till 2. And this slice will be taken 0, 1, 2. So 0, 1, 2 will be the output. And if you do ::-1, this is the standard way of reversing a string. So same can be applied to a list as well. The list can be reversed using : -1. How? So if you have like list : -1. So here the step size is given as -1 and start and stop are not given. So default values like complete list will be traversed. And step is -1, which means you will do right to left traversal. So you will traverse the list right to left and step size is -1. So every element will be taken. So the output will be the list containing elements 5, then 4, then 3, then 2, then 1 and then 0. So this will be the output. The reversed string. Okay. So the reversed list will be printed or 5, 4, 3, 2, 1, 0 will be printed on the screen. So this is how you can do slicing in lists. And same concepts for negative indexing will also work. You can use negative indexing as well, just like we did in strings. Same concept will work for list as well. Now you can loop through a list as well. We have already seen this concept when we discussed for loop. So you can use a for loop over a list because list is an iterable. You can use a for loop over a string as well because string is also an iterable. So you can loop over all the elements of a list using a for loop, and you can say for item in list 1, 2, 3. And list is an iterable, so it will give the items 1 and then 2 and then 3 in that order. So so item will first take the value 1, then 2, then 3. And we know that for loop works this way, right? For variable in iterable. So variable is item here. Item will take the value 1, then 2, then 3. So output will be 1, 2, 3. And you can loop through a list using a while loop as well. So let's say the list contains elements 5, 10 and 15. So you can use a while loop, but while loop is slightly tedious, right? So here what we are doing, variable I is initialized to 0. And we are using length of list. So you can actually find the length of the list using the len function. Len function was used to calculate the length of a string, which is the number of characters. The same function can be used to calculate the length of a list as well. It will give you the number of elements in the list. Okay. So here the number of elements is 1, 2 and 3. So in this list the length is 3. Okay, this length is 3. Now while I is less than 3, so currently 0 is less than 3, we will go inside print LST of 0, which means 0th element, which is 5, will be printed on the screen. So 5 will be printed and then I will be incremented by 1. So I will become 1. Now 1 is again less than 3, so list of 1 will be printed. 1 is what? 10. So 10 will be printed and then again I will be incremented by 1, which means I will become 2. Then 2 is again less than 3, so list of 2 will be printed, which is 15. And then I will be incremented by 3. 2, 3, and now 3 is not less than 3. 3 is equal to 3. So we will stop the while loop and come out. So all the elements of the list are printed here using the while loop. But again, if you have to loop over the elements of an iterable, it is better to use for loop because for loop is created for that purpose. You can use a while loop as well like this, but it is like more hectic. For loop is easier. Okay. And you can use the enumerate function as well with the for loop. Enumerate function gives you the index and the value both, the pair of index and value. This we covered in the for loop lecture, right? So like enumerate function will give you the index comma value pair. So firstly it will give you 0 comma the string A. So this is the 0th index and this is the first index. Then it will give you 1 comma the string B. And you are taking this index comma value in the variables index and val, idx and val. So when you print index and val, you will get 0 and A and then 1 and B. So this is how you can use the enumerate function while looping through a list as well. If you want the index along with the item both, then use the enumerate function. Now these are the operators on list, and we have seen the same operators for strings as well. So you can use the plus operator if you want to do concatenation of list. So you can actually add 2 lists as well, just like we can add 2 strings. If you add 2 strings, they concatenate. Similarly, if you add 2 lists, they also concatenate. So if you do list 1, 2 plus list 3, 4, it will create another list that will contain elements one after the other, which means 1, 2 and then 3, 4. So this list will be added to this list. The elements will not be added. All the elements in this list will be appended at the end of this list. So another list will be created if this list contains L1 items and this list contains L2 items, then the final list will contain L1 plus L2 different elements. Okay, so exactly same elements will be added at the end. So if you, let's say now, if you have a list containing elements 1 and 1, and if you add it to another list containing elements 1 and 1, then it will create another list containing 1, 1, 1, 1, like that. Okay. So this is how you can use the plus operator with lists. Now you can multiply a list with an integer. You cannot multiply two lists, that is not allowed. But you can multiply a list with an integer. So in strings, what happened? If you multiply a string with an integer, the same string is repeated those many times in a single string. Same happens in list as well. So if you do, let's say the list 1, 2 and you multiply it by 3, you will get another list containing 1, 2, 1, 2, 1, 2. So the same elements will be added 3 times, 1, 2, 1, 2, 1, 2. So now if you had 2 elements here, you will have 6 elements here. So if you do 0 into 3, you will get another list containing element 0, 0, 0 3 times. So this is how the multiplication operator works with list. Next we have membership. Membership is very simple. You can just check an element is present in a list or not. So if you do 3 in 1, 2, 3, 3 is present in this list, so you will get true. But if you say, let's say 4 in this list, you will get false. So this is how membership works. And similarly, not in will also work. Like not in is not mentioned, but if in works that way, not in will also work the similar way. It is just the opposite of in. Then we have length. You can calculate the length of the list using the length function, and like it will just give you the number of elements inside that particular list. And you can actually calculate the minimum element, maximum element, and the sum of elements inside a list as well. And this will only work for lists containing floating point numbers or integers. Okay. So if the numbers can be added actually, or like the minimum or maximum can be calculated, then only this will work. So if you calculate the minimum of 4, 7 and 2, if you want to calculate the minimum of all the elements inside a list, you can just use the min function. You can just use the min function. So let's say a list contains elements 10, 5, 7, 1, 3, and you say minimum of this list, minimum of A. It will give the minimum element of all the elements, which is 1. And if you do max of A, it will give you the maximum element inside the list, which is 10. And if you say sum of A, it will give you the sum of all the elements inside this list, which is 26. Okay, so this is how you can calculate the min, max and sum using the min, max and sum functions. And they are, you can apply them over a list as well. Okay. Okay, now let's see list modification operations. So we know that lists are mutable. So we can add elements to a list, we can delete elements from a list, and so on. So how to do that? There are predefined functions which you can apply on list that will work. So let us see these methods one by one. First is append method. It adds an item at the end of the list. So in the append function, you have to pass a value. It can be of any data type, again, because list can contain any data type item, and it will just append that particular item at the end of the list. So if you have list as 1, 2, list is containing elements 1 and 2, and we are saying list dot append 3. So if we do list dot append 3, which means this element will be added at the end of this list. So now the list, after this operation, when you print list will contain elements 1, 2 and 3. Now this can be any data type actually. Like if you, instead of 3, let's say you have a string hello. So this entire string will be added as the third element in this list. So list will now contain 1, 2 and then the string containing hello. And you can have another string as well. So if you have, let's say, if you say append 1, 2 or 3, 4. Very important question. So list is 1, 2 and we said list dot append 3, 4. So append function only appends a single element. It always appends a single element. So it will consider this entire list as a single element. So after this operation, what will happen? This list will contain elements 1, 2 and the third element will be a list itself containing the elements 3 and 4. Now this entire list is a single element. So the indices will be 0, 1 and 2. So after this operation is done, the size of the list will be 3, not 4. Okay. So after this operation, if someone asks you what is the size of list now, so you might think that 1, 2, 3, 4, there will be 4 elements. No, there will be 3 elements, 1, 2, and a list containing elements 3 and 4. So you will have 3 elements only, an integer and then another list. So there will be 3 elements, 0, 1 and 2 indices. So append function only appends a single element. It will consider this entire thing as a single element and it will append it. So you cannot pass 2 elements. You can never say list dot append 3, 4. Here you have passed 2 different values. This is not allowed. You can only pass a single value, and list can be considered as a single value, right? So this is allowed, and you will have the size of the list as 3 after the operation. So in this example, here we have 1, 2 and we append 3. After the appending is done, when you print the list, you will have 3 items 1, 2, 3. Okay. And this is another complicated example for the same. Now next is insert. So append function always appends the element at the end. But what if I want to append an element in the middle of the list or at the beginning? For that you have to use the insert function. In insert function you have to pass 2 values. First is the index. Where do you want to insert? First is the index and second is the value. Okay. So it inserts an item at index I. It inserts the item X at the index I. So if you have, let's say again, list containing the elements 1, 2, 3. And you say list dot insert 1, 100. Okay. So the indices right now are what? 1, 2, 3. The indices are 0, 1 and 2. So this is the list and these are the indices. So you are saying at index 1, you have to insert 100. So now at index 1, you will have the element 100 and all the elements which were at index 1 or after that, they will be shifted by 1 position. So you will insert at this position because you have to make this element as index 1. So now the elements will be 1, 100, 2 and 3. So now the indices are 0, 1, 2, 3. So after the updation, you can see 100 is inserted at index 1. So this is what you want. You don't have to insert here after 1. You have to insert before 1 because you have to make this element as index 1. So this is the correct answer. Okay. So this is how you can do it. So if you say list equal to 1, 2, 3 and you say list dot insert 1, 100 and you print list, you will have 100, 2 and 3. Now again, same concept, insert function also inserts a single element. You cannot have multiple elements here. And you can have a list, another list here as well. But that will be considered as a single element. So the same concept will be applying here as well. Okay, so this is how the insert function works. These functions are very important, okay? Append function, insert function, they are very important for exam perspective. Append, insert, both. Actually, all the list modification functions are important. Next is extend. Now, extend function will take argument as an iterable. You can give any iterable to it. And if you extend a list with an iterable, all the elements in the iterable will be added at the end of the previous list. For example, here we had list as the elements 1, 2 and 3. And we said list dot extend with the list 4, 5. Now observe that in the extend function you always have to give an iterable. This is an iterable, list is an iterable, right? You can take the elements one after them out of a list, 4 and 5. So what will happen? Now the list will contain elements 1, 2, 3 and now this will not be taken as a single element. In append function, the argument is taken as a single element. But in extend function, the argument, whatever argument is there, that is taken as an iterable and all its elements will be appended one by one. So firstly 4 will be appended, then 5 will be appended. So after this operation, the list will contain 5 elements. After this operation, the list will contain 5 elements, 1, 2, 3, 4 and 5. Because all the elements will be added to the end of it one by one. Now the previous example was this. So here if you append, then after this operation the list contains 3 items, 1, 2 and another list. But instead in the same example, if you do list dot extend, instead of append, if you do extend 3 and 4, then in this case the list was this. after the operation is done. 1, 2 and the list containing 3 and 4. But if you do extend, then the list will contain the elements 1, 2, 3 and 4. So it will contain 4 items at indices 0, 1, 2 and 3. But if you do append, it will contain indices 0, 1 and 2 and list will contain only 3 items. So this is the difference between append function and extend function. Append function takes a value and extend function takes an iterable. And extend function will append all the items inside the iterable at the end of the list. Okay. So be mindful, just see in exam carefully, you are asked append or extend function. Okay. So extend function takes an iterable, it extends the list with another list or iterable. So if you have a list containing elements 1, 2, 3, if you extend it by 4 and 5, then okay, let's see what will happen here. So if you extend it by 4 and 5, this is what the list will become. Now we have another extend. You extend it by range 6, 8. So after this operation, the list was 1, 2, 3, 4, 5. Now you have another extend with range of 6, 8. Range of 6, 8. So right now the list is this. Right now the list is this. And now we are doing range of 6, 8. So range of 6, 8 is another iterable and it will take values what? Start is 6, stop is 8 and step size is 1. So 6 and 7 and 8 is not included because the stopping point is exclusive. So these two elements again will be appended one by one. So after this operation, the list will contain elements 1, 2, 3, 4, 5, 6 and 7. And observe that append function or insert function or extend function, all three of them change the actual list which you are operating on. So the list which you are operating on, that is only changing. It is not returning another list. Because lists are mutable, you can't change the original list only. So all these functions actually change the original list itself. Okay, so here now the list, the same variable now contains the list 1, 2, 3, 4, 5, 6 and 7. So after this, the list will contain elements 1, 2, 3, 4, 5, 6 and 7. Now you have another extend, string ABC. So right now the list is this. And you are extending it with the string ABC. Strings are also iterable. Strings are also iterable and it will give the elements string A and then string B and then string C one by one. So all these will be appended at the end one by one. So list will now contain elements 1, 2, 3, 4, 5, 6, 7 will be as it is. And at the end you will have A, then B, then C. So after this operation, after these three lines, now the list contain all these elements. So what will be the size or length of the list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 will be the length of the list after you have performed all these three operations. And if you print the list, the output will be 1, 2, 3, 4, 5, 6, 7, A, B and C like this. Okay. So this is how the extend function works in Python. Okay, these three methods were for inserting elements. Append, insert and extend, very important. Now we have operations to delete elements. Okay, so if you want to remove items from a list, then the first function is pop function. Okay, it removes and returns item at index I. So in the pop function, you just have to give an index and any like an item present at that particular index will be removed. And it will also return that item. So you can print that particular like pop result as well. Okay. So let's see what will happen. It removes and returns the index at index I. If index not given, it removes the last element. Oh, okay. So if you don't give any index like this, if you just write pop function, it will just remove the last element. So here the list contains elements 1, 2, 3 and 4. So if you just do list.pop function and you have not given any index, so the last element will be removed from the list. So now the list contains elements 1, 2 and 3 only. And also if you print the output of the pop operation, you can also print the output of the pop operation. Here it will not print the list. So observe that, like what we are trying to say here. List contains elements 1, 2, 3, 4. When you do list.pop, it will like, so what is happening in memory, the list is stored as 1, 2, 3, 4. and the variable LST is pointing to this memory location. Let's say the memory location is 756. Okay. Now when you say list.pop, it will delete the last element of this list LST. So it will delete this last element. So now the list will only contain elements 1, 2 and 3. And it will also return the element it popped. The element which it removed was 4. So that will be returned. So this entire expression will now be substituted with the value 4. So if you print the output of this expression, if you print the expression itself, the output will be 4 because that is the element it deleted. So you can also take it in a variable. You can say that last element is equal to list.pop. So this will do two things. Firstly, 4 will be removed from the list, and also last element variable will contain the value 4. So that is what returning a value means. You can either print it or you can store it in another variable. Because after this operation is performed, this entire expression will now be substituted with that value. So it will return that value. This is very important. So it removes and returns the item at index I. Now after this is done, if you print the list, you will get the answer as 1, 2, 3 because list mein last element has been removed. Now if you do list.pop1, now list contains these elements and the indices are 0, 1 and 2. Now at this particular position, what they have said is the list now contains 3 elements 1, 2, 3, and we have said list.pop1, which means this 1 is the index. At this particular index, whatever item is there, you have to remove it. So this element will be removed from the list. And again, this entire expression will return the value which is removed, which is 2 will be returned. So this entire expression will be substituted with the value 2. So if you print the output of this expression, you will get 2. And the list now contains elements 1 and 3. So this element has been removed. Now the list contains only 2 items, 1 and 3, like this. Okay. So when you print the list, the items will be 1 and 3. Okay. So now here what happens if the index is out of bounds. So if you give a index which does not exist, okay, so you will get an index error. So the pop function will give you an error if the index does not exist. You have to be mindful, and the index which you are giving to the pop function should exist. It should be a meaningful index for that particular list. So index error will be there, pop from an empty list. So if the list is empty, you will get the error as pop from empty list. And if the list is already there and the index is out of bound, you will see the error as index is out of bounds. Okay. So if the list is empty or if the index is not meaningful, you will get the index error in Python. So this is how the pop function works. Now the next function which is used to remove items from a list is remove function. So pop function is used if you know the index of the item which you want to remove. But what if you don't know the index of the item which you want to remove? You just know what element you want to remove. Then you can use the remove function. So pop and remove are similar. Pop function is used to remove an item if you know the index of item that you want to remove. And the remove function is used if you know the item itself that has to be removed. Okay. So removes first occurrence of the value x, because now list can contain the same element multiple times as well. Okay. So you can have a list containing the same element 1, 1, 1, 3, 4, 1, 2 like this. Now same element can be present multiple times. So which one will it remove? The first occurrence. So let's say if you say this is the list, and if you say a dot remove 1, then 1 has to be removed. Then the first occurrence of 1 will be removed, not any other location. Okay. So it removes the first occurrence of the value x. So if you have a list as 1, 2, 3, 4 and you say list dot remove 3, then 3 will be removed from the list. And when you print the list will contain now elements 1, 2 and 4 like this. Okay. So this is how the remove function works. Now if you pass a value that is not there in the list, then again it will give you an error. Just like pop function, if the index is not a meaningful index or it is out of bounds, then it will give you error. Similarly, the remove function will also give you an error if the element that you are trying to remove is not in the list. So if right now the list contains elements 1, 2 and 4. And if you say list.remove 5, 5 is not present in the list. So we will get a value error, list.remove x, x not in list. X is not in the list and hence you are getting the error. So this is how the remove function works. And the next function to remove elements in a list is clear function. Clear function removes all the elements from the list. So it will just make the list empty. So if you want to remove all the elements from the list, you don't have to apply a for loop. You can just say list.clear function. So if the list contains 4 elements 1, 2, 3, 4, and if you just run this line list.clear, it will delete all the elements from the list. Now this variable will contain an empty list. Okay, all the elements will be deleted, and when you print the list, the size of it will be 0, length will be 0, and when you print the list, empty list will be printed on the screen. So these are the functions to insert elements and to remove elements from a list. Okay, now let's look at searching and counting methods for lists in Python. So first is index function. This is same as in strings as well. In index, the index function is there for strings as well. This will give you the index where that particular element is present. Now in strings, if you have to find an element, there are two methods, find function and index function, right? But in for list, find function is not available, only the index function is available. And also the find function for strings, it will search for substrings. But in list, if you are using the index function, it is only looking for a particular element, not a sublist or something like that. Okay, so like the searching is different in strings than in lists for Python. In list, you can find for a particular element. You can search for a particular element, and you can use the index function for that. So index, and here you can pass a value, and it will give you the index where that particular element is present. So it returns the index of the first occurrence of the value x, first occurrence, because a element can be present multiple times, and in that case, the first occurrence of the value, wherever it is present, that index will be given to you. So let's say the list contains elements 10, 20, and 30. And if you print list.index 20, then 20 is present at index 1. So index 1 will be given as the output. And if you do list.index 40, 40 is not present in the list. In that case, you will get a value error. Error will be there. Index function can only be used if the value is present in the list. So you have to be mindful. It will give you an error and the program will stop. So if you have to write the program correctly, if you have to search for an element x inside a list, let's say the program is like you have to search for element x inside the list A. Then if you just use a dot index x, then it will give you an error. It might give you an error if x is not present. So generally we write it like this: if x in A, then only we will search for index. Index is equal to a dot index x. This will not give you an error, because if x is not present in the list, you will not go inside this particular if condition and you will come out. So to be mindful, because index function can give you error and your program might stop, and hence always use the index function inside a wrapper, like inside a if condition, so that your program does not run into errors. Okay, so this is how you can write it. So this is how the index function works. Next is count function. Count function gives you the number of times a particular element is present in the list. So it counts how many times x appears in the list. Okay, so if the list is 10, 20, 30, and if you print list.count 20, 20 is present only one time. So output will be 1. So if the list had been like 20, 10, 20, 30, 20 like this, and if you do on this list, if you count number of times 20 is present, you will get 3. Okay, this is how it works. And if you print list.count 40, 40 is not present in this list, and hence you will get the output as 0. Now let's see a trick question on this. So let's say a list contains these elements 1, 2, 3, and then 2, 3, then a list containing 3, 2, 4. So here in this list, the first element is the integer 1, the second element is the integer 2, third element is the integer 3, fourth element is a list containing 2 and 3, and the fifth element is a list containing 3, 2 and 4. This is possible, right? Now if I say a dot count, let's say 2, then what will happen? How many times 2 is present? So 2 is present here, and you might say that 2 is present here and here as well. But this will not be counted as 2, because this element is not equal to 2. This element is a list. If you do 2, 3, is equal to 2, you will get false, right? Because they are not equal. It only compares entire element, and hence the count will only give you 1 as the answer. Only 1 times 2 is present. This is not 2 and this is also not 2. This is another list, right? And this is how the count function works. And same will happen for the searching as well. So if in this list you try to search for a dot index, let's say 2, you will get the index 1 because it is present at index 1. And if you do a dot index list containing 2 comma 3, so list containing 2 comma 3 is present inside this list at index 4, so you will get 4. And if you do a dot index list containing 3 comma 2 comma 4, then this exact same element is present at index number 5, so you will get 5. But if you do a dot index, let's say only list containing 3 comma 2 comma 4, then this element, this particular element, which is list containing 3 to 4, is not present in this list. The actual element that is present is a list containing 3 to 4. So this element is not present. This will give you error. So you have to search for exact same element, and be mindful that this is not equal to this, right? Because inside this list we have one element 1, but inside this list we have one element which is a list containing an element 1. So they are different. Okay? So this is how it works. It has to be exactly same for count and for searching. Next is sorting and reversing. If you have to sort a list or reverse a list, you have methods for that. So sort function just sorts the list in ascending order. So sorts list in place, which means at the same memory location, and in ascending order. So if you have a list like this, nums is equal to 4 to 7. And if you do nums dot sort, then this entire list will be sorted. Now it will contain 2, 4 and 7. So when you print nums, the output will be 2, 4 and 7. And you can sort it in reverse order as well. For that, you have to set reverse as true. Reverse is an argument in sort function. So you can set the reverse argument as true. By default, it is false. So if you set reverse is equal to true like this, inside the sort function, it will sort in reverse order. And when you print the nums list, now the output will be reverse order or descending order, 7, 4 and 2. And remember, it does in place sorting, which means the original list will be sorted at the same memory location. Okay, but what if, like if you have a use case in which you have a list, let's say 3, 1, 2, 4, and you want to keep this list as it is. You want to keep this list as it is, and you have to create another list that is the sorted version of this list. Then you cannot use the sort function. If you use the sort function, then this list will be gone, because at certain memory location, this will be stored 3, 1, 2, 4. And A will be pointing here. And when you use the sort function, the same list will be changed to 1, 2, 3, 4. Right? And the original list will be lost. So if you have a use case in which you want to keep the original list as it is and you want to sort it, for that in Python you have the sorted function. So sorted function is not just for lists. Okay, this sort function was we were applying on a list, like list dot sort. But sorted function is a standalone function, and you just don't have to apply it on list, you can apply it on any data structure. So how that works, let's see. Sorted function returns a new sorted list. So here in this case, the original list will be as it is, and a new list will be given to you. So again, let's say the list is A is equal to 2, 1, 3, 4. Okay, and if you do a dot sort, then this will change the initial list. It changes the original list and it will be lost. But if you use the sorted function, how to use the sorted function? You don't have to write like this. This is wrong. This is wrong. Sorted function works in a different way. You have to use the sorted function standalone, and inside the sorted function you have to pass the list like this. So if you use this function here, the list A will not be changed. List A will remain as it is. Original list A remains as it is. Okay, it will not change. So here again, like 2, 1, 3, 4 will be stored in memory, and A will be pointing here. And sorted A will give you another list. This will return you another list that will be a sorted version of this list. So this is, let's say, at memory location 756. This might be at memory location 891. Then this particular list will be returned, and you can store it in some other variable or print it. Let's say I say B is equal to this. Then B will be pointing at this memory location, and original list will remain as it is. So if you have such a use case in which you want to preserve the original list, you don't want to change its contents, then you can use the sorted function. And if you use the sort function, it will change the list itself. Okay, so let's say nums is equal to 427, and you do nums2 is equal to sorted of nums. Then if you print nums2, the sorted list will be printed, which is 247. And if you do sorted nums, reverse equal to true. Here also there is an argument, reverse is equal to true. So you can pass the list, and also you can set reverse as true. In that case, it will be sorted in reverse order, 742. And in both these cases, the original list nums remains as it is. Okay, it will be 427 only. So this is how the sorted function and the sort function works. Now we have a reverse function. Reverse function will just reverse the list in place. It reverses the list in place, which means at the same list will now be reversed. So nums is equal to 427, and if you do nums dot reverse, it will reverse the list, and now if you print nums, it will have 724, all the elements in reverse order. There is another way of achieving this. You can say nums. So if you want to do it like this is in place, but what if you want to make another copy again? That we already know. So here nums is 427, right? And if I do nums dot reverse, so in this case, the original list will go away. It will change. Original list will change to reversed list. To reversed list, right? And so in this case, what will happen if 427 is stored in memory? Let's say at memory location 736, and nums is pointing here. Then if you do nums dot reverse, this entire list will change, it will reverse 724 like this. But if you want to keep the original list as it is, and if you want to have another list, nums2, that contains the reverse list, then how to do that you already know. Take some time and think about it. You can do it using slicing, right? We have already seen. Slicing always gives you another list. Original list doesn't change. So if you want to keep the original list as it is like this, and if you do nums2 is equal to nums colon -1, this slicing will produce, slicing produces another list. Another list, original list is as it is. Okay, that will be as it is. So now here what will happen? Slicing will give you another list containing elements 724, and now nums2 will be pointing to this list. Let's say it is on memory location 819 or something. Okay, so this is how you can do reversing. Dot reverse function, and if you want to do out of place or another copy, then you can use slicing. Okay, so this is how you can do sorting and reversing of lists in Python. Okay, now let's see list copying. What if you want to copy a list from one variable to another? So essentially by copying we mean, let's say there is a list A as 1, 2, 3, and I want to create another variable, another copy of it in memory. So right now here the list 1, 2, 3 will be stored in memory at some memory location, and the variable A will be pointing to it. Now you want another copy of the same list in the memory, like another copy of the same list like this. You want to keep this list as it is, and you want to copy it at some other memory location, and maybe like point another variable to it. So for this, if you write B is equal to A, this is wrong. We already have seen this in memory and memory management and variable lecture. If you just write B is equal to A, this will copy the address of A in B. It will not copy the contents. It will copy the address. So if you write this, B will also start pointing to the same memory location, right? And hence this is wrong. It will not create a copy. It will just create another variable that will be pointing to the same memory location like this. So if you now do b.append 4, B will also be pointing to the same memory location. And when you do b.append 4, 4 will be appended to this string like this. right? And if you now print A is also pointing to the same memory location or the same list, and when you print it, 1, 2, 3, 4 will be printed. Although you did not append to A, you appended to B only, but B and A were pointing to the same memory location, and hence this happened. And that is why this is a wrong way of copying a list. So if you just do assignment, it will just point to the same reference or the same memory location. So this is the wrong way of assigning a list to another list or copying the contents. What you should do ideally, what is the proper way of copying? You can use the copy function to do that. So if you use the copy function, what will happen? Like if you have a list A as 1, 2, 3, and if you have a list, if you do B is equal to A dot copy, what will happen? This will create another copy. Copy function creates another copy of the same list. So 1, 2, 3 is stored in memory. Let's say at memory location 756. So A will be pointing here. Now when you say B is equal to A dot copy, copy function will create another copy of the entire list as it is 1, 2, 3 at some other memory location. And now B will be pointing to this particular memory location. And another way of achieving this is using slicing. Slicing always gives you another copy, right? Slicing creates another copy of the list. So it doesn't matter if you do A colon, that's all. So here we have not written start, stop or step. So what does it mean? Default value of step will be taken as 1. Default value of start will be taken as 0. And default value of stop will be taken as the length of the list. Length of the list is 3. So these are the indices 0, 1, 2. We will start at 0. We will stop at 2 because 3 is exclusive and step size will be 1. So entire copy of a list will be created and B will be assigned to it. Slicing always creates a copy of the list. The same logic we saw in reverse also, right? In reverse also, if we do -1, reverse of the list will be created in another copy. So you can use slicing or the copy function if you want to copy the elements in another memory location and point a variable to that. Okay, and there is another way is using copy library. In copy library, there are two copy functions, shallow copy and deep copy. We will take a look at that. What is the difference? So the deep copy function is used to create a deep like a copy of a particular list in another list. Now, why do we need shallow copy or deep copy? We will see. It is specifically used for nested lists. So to understand this statement, let's first look at what nested lists are. Okay, nested lists. So they are list inside a list. In Python, you can store a list inside a list and that list can contain another list and so on. You can have it at any level you want. So let us say we created a matrix like this. It is a list containing elements 1 and 2 and another list containing elements 3 and 4 like this. So here matrix is a variable. This is how actually you can create 2D arrays, 3D arrays in Python, okay, using nested lists. So if I write like this, list containing 1, 2 and list containing 3, 4 and we have a list. So this is a list containing like the variable name is matrix. So how many elements does the matrix list have? It has two elements, this list and this list, index 0 and index 1. Now at index 0, if I take it index 0, matrix of 0 is what? Matrix of 0 is a list containing two elements, 0 and 1. And similarly matrix of 1 is also a list containing elements 3 and 4 and the indices are 0 and 1. So if I print matrix of 0, this will be this list, and if you do another 0, it means that inside this list you have to take a look at index 0, then you will get the element 1. Similarly, if you take a look at matrix 1, 1, that means you are taking the look at the first element of the matrix, which is this list 3, 4, and inside this matrix you are taking a look at the first index, which is the element 4. So this is how you can print all the elements of the matrix. Matrix 0, 1, 0, 0, 0, 1 and 1, 0. This will give you all 4 elements of this matrix. So the 0, 1 pe what is there? 0, 1 means 2 and 1, 0 is 3, like this. Okay, so this is how you can create two-dimensional arrays. It is a two-dimensional array, right? It is a matrix like this, 1, 2, 3, 4. You can consider it like this. And similarly, you can create 3-dimensional arrays as well. So how do we create a 3D matrix in Python? Again, you can use lists, of lists, of lists. So let's say I create matrix as one comma 2, 3 comma 4, then okay, so this is the first list, and the second list is 5 comma 6 and 7 comma 8, something like this. Okay, so this is a 3-dimensional list. How? So if you take a look at matrix of 0, matrix of 0 is what? The first element of this list, which is this thing, and the second element is this thing. This is at index 0 and this is at index 1. So index 0 contains a list containing list 1 comma 2 and 3 comma 4, and matrix of 1 is a list containing 5 comma 6 and 7 comma 8, like this. So this is at index 0, this is at index 1, this is at index 0, and this is at index 1. Now if I take a look at matrix 0, 0, so which means matrix 0th element, it is another list containing elements 1 and 2 at index 0 and 1. So if I take a look at matrix 0, 0, 0, then I will get the element 1. Similarly, in the same array, let's say I ask you what is matrix, let's say 1, 0, 1. Then matrix 1 is this entire list, then 0th element of that is this list, and then first element of this is this element, which is 6. So that is how you can create 3-dimensional matrices as well. So these are called nested lists or matrices. Okay, they are lists within lists. So if this is the matrix, if you print matrix 0, then the list 1 comma 2 will be printed. And if you print matrix 0, 1, then the first element of this list, which is 2, will be printed. Okay, always 0 indexing will be there. So now storage wise actually Python handles matrices in a different way than C++ or C programming language. In C, C++ or Java, we have row major order and column major order to store matrices, right? But in Python it is not like that. In Python actually, how will this be stored in memory? Let us see that. So if I create a matrix like this, matrix is this particular matrix 1, 2 and 3, 4. So storage wise what happens? Since the first element of this list is itself a list, firstly this list will be stored in memory somewhere, let's say 1 comma 2. This list is stored at memory location 123, let's say, or let's take some other memory location, let's say 512. Okay, and then second element of this list is also a list, so this will also be stored in memory somewhere. Let's say it is stored like this 3 comma 4 and it is stored at 6 2 4. Okay, something like that. Address is this. Then when you create this matrix, it will just store the addresses. It will just store the addresses. So what will happen? This particular element will point to this list and this particular element will point to this list. That's all. And this is like, let's say at memory location 756, and the matrix variable will be pointing here like this. So this is how internally it is stored in memory. All the lists which are there inside a list, they are separately stored at some other memory location, and at that particular position there is just a pointer to that particular memory location. Okay, so this is how internally it handles. So they are not stored in one continuous memory location. If you have multiple lists inside a list, they will all be stored at some other memory locations and only the pointers will be present. So now if you have, let's say, another, let's say there is a list containing 3 and a list containing 1 comma 2 inside of it. Okay, so this is your list, let's say. So the third element is what? It is a list. Third element is itself a list. So it will be pointing to a list. Now this list contains the first element as 3 and the second element is another list. So it will point to another list stored in memory, which is storing the values 1 and 2 like this. So here there are three elements, 0, 1 and 2. So the three elements are 0, 1 and 2. First is a pointer to a list containing 1 and 2. Second is a pointer to a list containing 3 and 4. And third is a pointer to a list. Okay, so this is wrong. Here, like I assumed that this element is present directly. Let's say this is the list. Okay. So the third element points to a list. Firstly, it contains a value 3. And the second element is a list containing values 1 and 2. So it will point to a list containing values 1 and 2. The previous one which I wrote will point to another list as well. Okay, so this is the correct representation. And everything will have an address. Let's say this has an address 813, this has an address 907, something like that. So it will only point. And it is not guaranteed that all of these values will be stored in memory in a continuous form. Okay, in C++ and other languages, when you create 2D arrays, 3D arrays, it is guaranteed that you will, like, all the memory locations will be continuous, and that's why we call it row major order or column major order. But it is not the concept in Python. Okay, they are all stored here and there, and only pointers are stored. So this is how internally lists within lists are handled in memory in Python. Okay. So memory behavior in nested list. When we create a nested list, a equal to 1, 2 and 3, 4, each inner list like 1, 2 and 3, 4 is a separate object in memory, and the outer list contains references or pointers to these objects. So this is the exact same point. So if you have a list containing 1, 2 will be stored in memory. Let's say at memory location 563, and at another memory location 3, 4 will be stored. Let's say at memory location 612. Then you will have this list A. It will just store the pointers to these memory locations. It will point to location 563 and it will point to location 612. And now A variable will be pointing at this memory location. Let's say it is at 713. Okay. So now when you perform B is equal to A, if you perform B is equal to A, what will it do? If you just write B is equal to A, B will also point to this memory location. If you change something at B, A will also change. This we already know. But the problem is, even if you write B is equal to A dot copy, what will happen? Think about it. If you write B is equal to A dot copy function does what? It will just create a exact copy of the list, right? So in the previous slide, we saw that to prevent this, we write this. But I am saying that even here, this is also a problem, because internally only memory locations or references are stored. And now let us see why is this a problem. Okay, so we are not creating a new list, just creating a new reference to the same memory location. This we already know. B equal to A is incorrect if you want to create a copy. So firstly, let us look at this example, like what is happening here. So 1, 2 is stored, and then 3, 4 is stored. The indices are 0, 1, 0, 1, and A is a variable that contains a list that is pointing to this list, and it is pointing to this list. This is the variable A. A is pointing here. I am not writing the addresses right now. I think you can imagine an address, okay? And when we write B is equal to A, B is also pointing to the same list, okay? So when you write B00 is equal to 99, what will happen? B0 is what? This particular memory location, which means this list. B0 means this list. It will point to this list. And B00 means what? This memory location, right? And when you write B00 equal to 99, this memory location will be rewritten, and the value written now will be 99. It will be rewritten to 99. That's what will happen. So now same changes will be reflected to A as well. So when you print the list A now, if you print the list A now, you will get 99, 2 and 3, 4, because the first element is 99, 2. List containing 99, 2, and the second element is a list containing 3, 4. So A also changes. Okay. And now what happens if you do dot copy function? What happens if you use dot copy function? Just tell me that. Instead of B equal to A, we have now written B is equal to A dot copy. So again, let's say A is given as the list 1, 2 and 3, 4. So 1, 2 will be stored in memory, and 3, 4 will be stored in memory. Let's say this is memory location 512, this is 634, and A as a list is stored at 712. It is pointing here, this one is pointing here, and A is pointing here. Okay, when I write b is equal to a dot copy, copy function creates a copy of the same list, exactly same list, a copy will be created. Another copy is created, let's say at memory location 834. Still the pointers are same. This is pointing to 512, this will also point to 512. This is pointing to 634, this will still point to 634 because the pointers are copied as it is. The pointers will be copied as it is if you use the copy function. And now b will be pointing here, right? So if it is a one-dimensional list, if it does not contain any other list, then copy function works great. But here in this case, now if you change b, if you say b00 is equal to 99, b0 is what? This list. b0 is equal to 99 means this element will be changed to 99. Now still a also points to the same memory location. Even though you created a copy, still a is also changed. If you print a now, what will you get? List containing 99 and 2 and list containing 3 and 4. So even after using the slicing function, even if you do b is equal to a and slice like this, same thing will happen, right? Because the memory references are copied as it is. Another copy of the lists are not done. Only the outer list is copied. Only the outermost list is copied. Inner lists are not copied because their memory locations are copied as it is. And this type of copy is called as shallow copy in Python. Shallow copy means only copying the outer list. See, b is equal to a is not even a copy. B is equal to a is not a shallow copy. This is not even a copy. This is just a reference assignment. You are just assigning the same address to b as was stored in a. This was just reference assignment. This was not, you are not even creating a copy here. But if you use the copy function or slicing, here what happens? You are actually doing a copy, but only for the outermost list. Inner lists are not copied, their memory references remain as it is, and that is why it is called a shallow copy. Okay. So using list.copy or copy.copy function, in copy library also there is a copy function. Okay, as I told you here. In this slide we saw, right? If you import copy library, you can use copy.copy function, not deep copy. If you use copy.copy function, like this also creates a shallow copy. Or even directly the copy function, that also creates a shallow copy. Shallow copy means only the outer list is copied, inside that the lists are same. So here also if you print a, even if you are using copy function, still the list a will change. 99, 2 and 3, 4 will be printed. This only copies the outer list, not the inner list. And this entire thing is called shallow copy in Python. Now what if you want to do a deep copy? Deep copy means you want to make a copy of every list, no matter how deeply it is embedded. Then you have to make a deep copy. That is the difference between shallow and deep copy in Python. And to create a deep copy, you need to use the copy library. Inside the copy library, there is a function called deep copy. Deep copy function will create a deep copy, which means every list will be copied. So now let's see this code. Here A is 1, 2, 3, 4. So here 1, 2 will be stored and 3, 4 will be stored. Let's say 5, 1, 2, 5, 3, 4, and the matrix A is stored at 576, and this is pointing here, this is pointing here, and A is pointing here. Now if you import the copy library and if you use copy.deepcopy of A, B is equal to copy.deepcopy of A. What deep copy does, it will copy everything. So firstly it will make a copy of this list, and inside this list it will see it points to a list. So a copy of this list will be created. Let's say this is at memory location 676. So a copy of that particular list will be created. Let's say at memory location 605. A copy will be created and this will be pointing here. And now the second object also points to a list. So a copy of this list will be created. So 3, 4 will be stored here. Let's say at 637. And this will be pointing here. And B will be pointing here. This is what it will do. Everything will be copied. So now if you change B, Now if you change B, it will not affect A, right? So if you say B00 is equal to 99, this element will change to 99. If you print A will remain as it is, B will be this thing. This is what deep copy in Python means. Shallow copy means only copying the outer list. Deep copy means copying every list which is embedded inside a list. You can have it to multiple levels as well. Deep copy will create a copy of every such list. Okay? So this is how deep copy works in Python. So to avoid shared references for a nested structure, use deep copy. Okay, so now let's look at list comprehensions. So what do we mean by list comprehension? Using a loop inside list creation. We know that we can create a list using square brackets like this. So here the list contains 4 elements, 1, 2, 3, 4. But what if I want to create a list containing 100 elements? So one way of doing that will be, let's say I want to create a list which contains elements from 1 to 100. So I can create a list like this, empty list. Then I can say that for I in range 1 to 101. So this range function will give me numbers from 1 to 100. Then I can say a dot append I. A dot append I. So this append function will append the value of I inside A. So after this, if I print A, what will I get? I will get a list containing numbers 1, 2, 3 and so on up till 100. 100 elements in the list. Right? So you can actually write this entire piece of code in a single line in Python. You can write this entire piece of code till here. Okay? So in a single line inside the list itself, if you want to use a for loop, you can use list comprehensions. And the syntax is list expression for item in iterable. Expression for item in iterable. So the same code can be rewritten as list I for I in range 1 to 101, like this. That's all. So for I in range 101, what do we want to do? Inside the list, I just want to store I. So here I am writing expression. Expression, this expression involves this variable as well. So for variable in iterable, this is my iterable. So this expression will generally always involve the variable as well. Here I want to store the variable itself. What if I want to store the squares of them? I can store the square as well. I can write I into I. So whatever we are appending here, we can write here. Right? So I want to store I. So I for I in range 1 to 101. So I will take values 1 to 100 and we are in the list, we are just storing I itself. So this one line will be a substitute for this entire thing, and this is called list comprehension. Okay? Expression for item in iterable. So this is equivalent of writing result is equal to empty list. Then for item in iterable, result dot append expression. We are just appending the expression. So these 3 lines are equivalent of writing this single line, and it is called list comprehension. Okay? So here the expression was I itself, because we were actually appending I. What if we wanted to do something else related to item, we can do that as well, and we can write the same expression here. So let us see some examples. So first example is squares is equal to x to the power 2 for x in range 5. So range 5 takes values what? 0, 1, 2, 3 and 4. So x will take values 0, then 1, then 2, then 3, then 4. So x square will take values what? X square, like 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9 and 4 square is 16. So we are storing x square, we are not storing x here. We wanted to store the squares of x. We can do that as well. So here the expression is x square, x to the power 2. So the values in the squares will be, it is a list containing values 0, 1, 4, 9 and 16, like that. So in a single line we can do that. Similarly, what if I want to add some conditioning as well? I want to go inside this range, but I want to skip a few values. For that I can write the if condition. So like what I want to do is, let's say I want to store the squares, but I only want to store the even squares. I don't want to store the odd squares. See, the square values for 0, 1, 2, 3 and 4 were 0, 1, 4, 9 and 16. I don't want to store 1 and 9. I only want to store 0, 4 and 16. Only the squares which are even. So for that the for loop will be, let's say the variable is squares is empty list, and then I'm saying for I in range 5 if I into I modulo 2, sorry, I into I or I to the power 2, whatever you want to write, I square is divisible by 2. Only in that case I want to append it. Squares dot append I to the power 2. So I can write this entire logic also in a single line of code like this. So just observe, x square for x in range 10, for x in range 10 means x will take the values, so here range 10 is there, okay, so let's say we want to do it till 10. Range 10 will take values 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So x will take values 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. X will take these 10 values. And I want to store x square. I don't want to store x. I want to store x square, which means a square of these values. But only if x modulo 2 is equal to 0. So they are not conditioning it on x square. They are only conditioning it on x. Here they are conditioning it on x, not on x square. Which means they want to store the squares of even numbers. They only want to store the squares of even numbers. And actually, if you think about it, both the conditions are same only. Because the squares of even numbers are even and squares of odd numbers are odd. So you can condition on the square also and you can condition on the number also. So both the conditions are fine. Here you can write here I also. And actually this piece of code is here they have x. This entire piece of code which is written here can be translated into a for loop like this. So even squares is the array. Let's say this is the even squares. Even squares is the array and here we are appending in even squares. Okay, or let's just call it squares only because of indentation issue. So this entire piece of code is written in a single line like this. So this condition also you can write here after the expression. So here what you are doing, expression, then for item in iterable, and then you can write the condition as well. Okay, so what will happen, x will take all these values and we are storing x square, but only and only if this condition is satisfied. So if x modulo 2 is 0, only for those numbers we will store the squares. So firstly this condition will be checked. So is x modulo 2 0? Yes, for 0 it is true. So x square will be stored, which means 0 will be stored. Now for 1, x equal to 1, 1 modulo 2 is not 0. So this value will be skipped. For this value will not be stored in the list. For 2 it will be satisfied, for 3 it will not satisfy, for 4 it will satisfy, 5 not, 6 yes, 7 not, 8 yes, 9 not and 0 yes. So for only for the values which satisfy the condition, we will store the squares and the output will be 0, 4, 16, 36 and 64, which is 0 square, 2 square, 4 square, 6 square and 8 square, and the odd numbers are skipped. That is how you can actually inside the list comprehension write a condition as well. Okay, again in the demo we will see more such examples. Now you can actually use if and else both. Okay, so if you want to use if and else both, there is a different way of writing it. If you only want to use the if condition, you have to write it after the loop. But if you want to use if and else both, then the condition becomes a little bit different. So here let's see. So what are we doing? Here we are saying labels is equal to even if x modulo 2 is 0, else odd for x in range 5. So here this is my expression. There are two expressions. See, if you have only if, then you will have only a single expression, because in this case you only had if condition, so you had only a single expression. But if you have else also, then you want to, let's say, append something else. You want to append, let's say, odd, string odd. Then you have two expressions. This is the first expression, this is the second expression, right, for if and else. So here we have to write two expressions. So this is my expression 1, this is what I want to append, this is my expression 2. So we are saying expression 1, if this condition is true, this is the ternary operator, standard way of writing ternary operator. So expression 1, if the condition is true, and if this condition is false, else this value, this expression, right? So this is the ternary operator. We have just written the ternary operator if else in a single line. And then after that I have written the range for x in range 5. So x will take the values 0, 1, 2, 3 and 4. And if x modulo 2 is 0, which means for even numbers you will write even, and for odd numbers you will write odd. So firstly x will take value 0. 0 is an even number, so you will add even in the list. Then for x equal to 1, 1 is an odd number, so you will add odd string in the list. Now again x will take 2. 2 is an even number, so even will be added in the list. So the expression is the string even itself, so even will be added. Now x will take 3. 3 is an odd number, so odd will be added in the list. Now x is 4. 4 is an even number, so even will be added in the list. Okay, this is how it is done. Let us take one more example. Let me give you one more expression here. Let's say you want to create a list something like this. Firstly, let me give you the logic, then we will write the list comprehension. Okay, so let's do it here. So the logic is something like this. Let's say you want to create a list named A, and for x in range 10, what you want to do is, if x modulo 3 is 0, which means every number which is divisible by 3, you want to append the number itself, and otherwise you want to append, let's say 0. Then what will you do? So here this is my first expression, this is my second expression, okay, and this is my condition. So overall, after this piece of code, like what will happen, x will take the values 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? And in the list A, after this entire expression, the list A will contain what? For all the numbers which are divisible by 3, which means 0, 3 and 6 and 9, we will append the value x itself. Or we can make it something else also, like you can make it, okay, let's keep it x. Let's keep it x. And here, let's keep it 0, okay. So 0, 3, 6 and 9 will remain as it is. And rest all numbers will become 0. So for 1 we will append 0, for 2 we will append 0, for 3 we will append 3 itself, 4 will become 0, 5 will become 0, 6 will be as it is, 7 will become 0, 8 will become 0 and 9 will remain as it is. And 0 will remain as it is, but it is 0 itself. Or you want, like if you want, you can make it -1. Let's append -1, okay. Then the list will be 0, -1, -1, 3, then -1, -1, 6, then -1, -1, 9. Right? This is what the list will be. Now, if you have to write this entire piece of code in a list comprehension, how will you do it? You will say A is equal to list, and if the condition is true, you want to append x itself. So you will write x. This is the expression 1. Expression 1, if x modulo 3 is equal to 0. So this is my condition. This is my expression 1. This is my expression 2. This is my condition. And this is my loop. Okay. So x, if x modulo 3 is 0, else I want to append -1. So -1. Now again for x in range 10. So here in the list we write expression 1 here, expression 2 here, condition and the else statement here, and the loop part here. This is how you can write a list comprehension with if else in a single line. And if you just have if, you will write the loop first and then if the condition, okay. So this is how it is done, the loop comprehension in list comprehension basically, okay. So, and you can do it using on nested loops as well, okay, like a loop inside a loop. You can have 2 loops also. So this is some advanced concept, like if you are able to understand it, it's good. Again, if you solve like a lot of problems like this, if you try to write it in a single line, you'll understand it, okay. But coming to exams, this is not like that much important, because like this is like some advanced stuff. But at least list comprehension with if else you should know. Now what you can do is, you can write 2 for loops also in a single list. So here what we are doing pairs is equal to tuple x comma y. This is an element, tuple x comma y. We will see in the next lecture, this is how you can create tuples, okay. So a pair x comma y for x in range 2, for y in range 3. So this is equivalent of writing, you have an empty list pairs and you are saying for x in range 2, for y in range 3. You are saying pairs dot append the pair, like the tuple x comma y. So these two for loops you can write in a single way. So this is the outer loop, this is the inner loop. This is the outer loop, this is the inner loop. Okay. So at the end of the day, what will happen? X will take values 0 and 1. Y will take values 0, 1 and 2. So firstly, it will take the pair 0, 0. So the pairs array, the pairs list will contain 0, 0 pair, then 0, 1, then 0, 2, then 1, 0, then 1, 1, then 1, 2. You can solve this for loop and you will see this will what the pairs will contain. Here also you will be able to create the same list pairs. Okay. So this is equivalent of writing this entire piece of code, and that's what I said. Okay. So you can add two nested loops inside the same list comprehension as well. Now you can similarly you can flatten a 2D list as well. So what we are doing here, we are again having two for loops. So here we are saying item. If we are doing an expression here, we have actually written an expression. Here the expression was the pair x comma y, but here the expression is just the item. Again follow the same logic. This code will be equivalent of writing flat. So flat is an empty list initially, and we are saying expression is item. This is what the value is that will append at the end. For row in matrix, so just write the same thing. For row in matrix. Now we have for item in row. For item in row. Then we are saying append item. Append the item itself. So we will say flat dot append item. The expression, whatever expression is there. So here in the previous example, the expression was pair x comma y. So we appended the pair x comma y. Similarly, here we will append item. So now if the matrix contains this elements 1, 2, 3, 4, 5, 6, like that is a 2D array matrix, right? So firstly for row in matrix means row will first take this value. Row will be this list. Then row will be this list. Then row will be this list. Now when the row is this list 1, 2, we are again iterating over all the items of the row, which means first 1 and then 2. Item will take the value 1, then 2. Then when row becomes 3, 4, item will take value 3 and then 4. Then when row becomes 5, 6, item will take value 5 and then 6. And we are just appending individual items in the list flat. So at the end of the day, flat will contain 1, then 2, then 3, then 4, then 5, then 6. So this is a single line that can convert a 2D list into a one-dimensional list. This was a 2D list. Using a single line, I can convert this 2D list into a one-dimensional list like this. This is also called flattening of a list. Flattening means converting higher dimensional list into a lower dimensional list. Okay. So the output will be this. So this is how you can use list comprehensions in Python. Okay, now let's see a common pitfall when you are doing shallow and deep copy. So let's say you want to create a matrix, like you want to create a list of list like this. So in competitive programming, there will be a lot of cases in which you require a 2D array or a 2D list of a huge size. Let's say this is 3 cross 3. This is a 3 cross 3 grid containing all zeros, right? So if this is my array A, I can say array of 1, 1, which means the first element and inside that the first element, like this one. So I can change it to 3, let's say I can do that. So I have control over 9 elements like this. It's a 3 cross 3 grid. Right, and I have control over all of them. I can do that. So this is a correct way of doing this. You can create a list like this, but this is not scalable, right? For 3 cross 3 grid you can write like this, but what if you want to create a 10 cross 10 grid? You cannot write like this, or like 100 cross 100 grid. And in competitive programming you will require very large size grids, for example 1000 cross 1000, something like that. You will not be able to create like that. So we know that 0 into 3 gives what? This will give you a list of size like 0, 0, 0 will be copied 3 times. For now, let's say I want to create a grid of size m cross n, which means m rows and every row contains n columns. Okay, So I can do like 0 into n. So it will be 0, 0, 0 n times. Then the common mistake which people make is, let's say now you want to create a 3 cross 3 grid. You can write it like this, a list containing 0 into 3 times, because what will it do? This will create a list. So essentially this is like writing 0, 0, 0 3 times, which means this will just copy this particular list 3 times, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? But actually internally what happens when you do into 3? See, this was okay, till here it was okay. But this is a problem. If you copy this list 3 times, when you do into 3 creates a shallow copy. It will not create a hard copy. So what will happen? This 0, 0, 0 will be stored in a memory only once. And let's say it is at memory location 123. Then when you do 0, 0, 0 into 3, an array will be created, and all these 3 objects will be pointing to the same memory location. It will not create the copy of this list 3 times. It will not create a deep copy. So when you write something like this, let's say 0 into n into m, ideally it should create an m cross n list, m cross n grid. It will create an m cross n grid. But the problem is this internal list will be 0 present n times. But the outer grid will be an array of size m or a list of size m, but they all will be pointing to the same memory location. They will all be pointing to the same list. So you will not have control over all the 9 elements at once. So if you write this statement 0 into 3 into 3, you will not have control over all the 9 elements, because internally what will be happening? Let's create a shorter diagram. Here if you write this statement, 0, 0, 0 will be stored in memory, let's say at memory location 123, and A is the array in which you are assigning it. Then A will be pointing here, and here all the 3 elements will be pointing to the same memory location, and let's say this is at memory location 256. Okay, so if you change some element, let's say you change A00 now. A00 is what? So this is the 0th element, this is the first element, this is the second element. Here this is the 0th element, first element, second element. A0 means this list, and inside that 0 means this element. If you change it to 1, this element will be changed to 1, and actually all these 3 are pointing to the same list. So when you print A now, what will happen? 100, 100, 100 will be printed. That is what is given here. So if you create the list like this, A is equal to 0 into 3 into 3, or you can create a m cross n grid as well, like into n into m cross n grid. But if you change any one element, all the rows will change because they are all pointing to the same list. So into 3 if you are using the multiplication operator, that will not create a deep copy. You want actually control over all the 9 elements separately. For that, you need to use list comprehension instead, or you can use a for loop. So this happens because all the rows refer to the same inner list. Instead of this, if you use a list comprehension, or even if you use a for loop, what you ideally want is, you want something like this. You want A be to an empty list, and you want for I in range 3, for I in range 3, what do we want? We want A dot append. We want A dot append 0 into 3. So every time when you are doing A dot append 0 into 3, a new list will be created of size 3. So initially when I is 0, so range 3 will take 3 values, 0, 1 and 2. So when I will take values 0 into 3 will be created, let's say at memory location 123, then it will be inserted inside the list A. This is the list A. So this will point here. Now when I will take the value 1, again 0 into 3 will be created. Again 0 into 3 will be created because it is not interned. So the compiler doesn't know it is already present. It will be again created. 0 into 3 will be created, let's say at memory location 245, and the second element will point here. And again when I will take value 2, then again 0 into 3 will be created, let's say at memory location 356, and this will be pointing here, and let's say A is present at memory location 457 or something like that. So this is what you want. So you should create it using the for loop, and we know that you can write this entire for loop in a single line like this. A is what? A list containing what? Expression is what? 0 into 3. 0 into 3 for I in range 3. And actually inside a for loop, see, in the expression I am not using I. Inside the expression I am not using I. So actually I am not using the value of I at all. I can actually replace this I with an underscore also. If you are not using the variable itself inside the loop, you can just make an underscore here, because underscore is a variable that replaces any value. You cannot use it. You cannot use underscore inside like anywhere. So you can just use underscore. Underscore is a better practice. If you are not using the variable inside the loop, you can just replace it with an underscore. So you can write an underscore here as well, because we were not using I inside the expression or inside the loop. Okay. So this, using list comprehension, you can write a statement like this, and this will create a 3x3 grid. Each row will be a separate object. It will have 3 different lists, 3 different copies, and you can change one element here. If you change A00 to 1 here, this will change. These two will still remain 00. Okay. So this is how you should do it. This is a common pitfall. Do not create an m cross n grid like this. Again, in the demo, we will try to create it and see what happens. Okay. Now let's see some examples on lists in Python. First is this. What is the output of the following code? A is equal to 1, 2, 3, B is equal to A, B dot append 4, print A. So A is the list 1, 2, 3, and when you write B is equal to A, B will also point to the same memory location A is pointing to. Here we are not creating a copy. This is not creating a copy. This is what? Assigning the reference. Assigning reference, not creating copy. So B will also point to the same list. When you do B dot append 4, same list will change. And when you print A or B both are pointing to the same list. And hence 1, 2, 3, 4 will be printed. If you need more information, here 1, 2, 3 will be stored in memory like this. A will be pointing here. When you say B is equal to A, B also points here. And when you say B dot append 4, 4 is appended here. And when you print A, 1, 2, 3, 4 only will be printed. Okay. So remember, here the copy is not made, only the reference is assigned. So correct option is option B. Okay, let's look at the next example. What will be the output of the following code? Numerical answer type question. A is equal to the list 1, 2, 3. B is equal to A colon, which means here we are creating a copy. Slicing always creates a copy. So A is the list 1, 2, 3. A is pointing to the memory location 1, 2, 3. And when you said B is equal to A colon, means you have to take the entire slice. Start and stop are default. Step size is 1. So entire copy will be created. 1, 2, 3 entire slice will be taken, and B will be pointing here. A new list is created. Now when you say B0 is equal to 10, this element will change to 10. And when you print A0 plus B0, 1 plus 10, which is 11, will be printed on the screen. Okay. So when you do a copy, like using slicing or using the copy function, a new copy will be created. Okay, so the answer will be 11. Now let's look at this question. What does the following list comprehension produce? I for I in range 3 for underscore in range 3. Okay, so I for I in range 3. So what is this list? Range 3 produces values 0, 1 and 2. And when I takes the value 0, 1 and 2, this list will contain the values 0, 1 and 2. So it is like writing the list containing 0, 1 and 2 for underscore in range 3. So this range 3 again takes the value 0, 1, 2. Right. So this is the correct way of assigning actually. So here what will happen? Underscore will take the value 0, and hence inside the list, firstly you will insert this particular element. This is the expression. So 0, 1, 2 will be added. Then another, like when underscore will take value, another 0, 1, 2 will be added, and a copy will be made, because you are doing it in a list comprehension. So a copy will be made. You are not using the multiplication operator. So it is correct. Okay. So this list will contain 0, 1, 2. Then another 0, 1, 2. Then again underscore will take value 2. Then another 0, 1, 2 will be added. And all of them will be different. You will have 9 different values, and you will have control over all of them. So when you do list 0, 0 equal to 99, this value will be changed to 99. And when you print the list 9912 012 012 will be printed. Because you were using list comprehension, this is the correct way of initializing a 3x3 grid. So 9912 012 012, which is option B. So option B is correct. Okay. Now these are some exercises on lists in Python. You can try solving them on your own first, and then in the demo we will solve a few of them, and we will see hands-on in Python. Firstly, try to solve all of them on your own. And this is all about lists in Python. What are different operators on lists? What are different methods which are useful on lists in Python? Now let's move to a demo. So now let's look at a demo on lists in Python. So we have seen like what lists are. Firstly, how do we create list? So initially in the class, like the first thing that we saw was creating an empty list. So always when you have to create an empty list, actually lists are always created using square brackets, right? And if you don't write any element inside it, it will be an empty list. So if I print the empty list now, let's do a few things. Let's print the empty list. Let's also print the type of empty list. And let's also print the length of the empty list. Okay, so length basically gives us how many elements are there in the list. So the name of the variable is empty underscore list, and I am printing the list, type, and the length. So the list is empty list, class is list, which means the type is list, and the length is 0. Okay, so this is how you can create an empty list in Python. Now we can create homogeneous list and heterogeneous lists both. So if I just create a list of numbers, it can contain like same type of variables, let's say all integers. Again, if I do all these things for numbers, I can do that. So the same list will be printed, the type will be again list, and the length will be 4 now. There are 4 elements in the list. And we can do the same thing for an heterogeneous list as well. Let's say I have a variable called mixed, and inside this I add a number, integer, and a floating point number, and a boolean value, and let's say a string. I can have another collection inside a collection. Okay, so let's say I have a string, and I have a complex number, let's say as well, 3 plus 5j. Now I can do all these things for this list mixed as well. So here we have mixed. So if I print mixed, the type of mixed and the length of mixed, the mixed is this list. It is a type list, and there are 5 elements inside this: 1, 2, 3, 4, and 5. They are all of different types, and this is also allowed. You can have any type of elements, and it can be mixed as well. So this is how you can create list using square brackets. Okay, now let's see how do we create lists using list constructor. So again, let's try to create an empty list. So how do we use the list constructor? You can just use the same class name. Class name was list. So you can use this and like consider it as a function for now. We will later see what constructors are. So list, and then if I don't add anything inside the brackets, it will create an empty list. So again, for the same list, let's just only print it. Like I think you've already got the idea. So if I print the empty list now, what will happen? An empty list will be printed. So this is how you can create an empty list, okay, using the constructor. Okay, I think, yeah, cool. And similarly, now we can create, use the constructor, and inside the constructor we can pass any collection. If you pass any collection, it will convert that collection into a list. So which means you can pass another list, but that doesn't make sense, right? Like you pass another list and then again convert it into list. But you can pass a set or a tuple or a string, and it will convert it into a list. Okay, so let's see. Let's create a list containing characters of the string gate. So I have a string gate, let's say, and if I convert it into a list, all the different characters will be given one by one. So you can pass any iterator, actually, not just a collection. You can pass any iterator, and it will convert the iterator into a list. So if I print chars now, okay, so it will print all the characters one by one in a list. And similarly, we can give the range function as well. So if I write like let's say the name is lst list, I cannot use list. List is a keyword. List list is a keyword, and you cannot use as a identifier, and hence I have used lst instead. Okay, so if I pass the range function, because range function is also an iterator, let's say from 1 to 6. So the starting point is 1, the stopping point is 6. By default, the step size is 1 and stopping point is not included. So if I print this list, what will be the elements? 1, 2, 3, 4 and 5. So these are present in a list now. So this is how you can use the constructor, and you can create a list by passing an iterator to it. Now let's see indexing and slicing in a list. Okay, so you can access elements in a list. We can do that just like strings. We can access any element in a list using its index. So if I have a list, let's say it contains different type of elements. First is a string, and second is an integer, third is a floating point number, and fourth is a boolean value. So if I print LST of 0, I can print LST of 0, 1, 2 and 3. Just like strings, here we have 4 elements, so the positive indices will go from 0 to length of string minus 1, length of list minus 1. So here at 0th index we have the string A, at first index we have the integer 2, at second index we have the floating point number 0.1, and at the third index we have the boolean value 3. If we try to go outside the boundary, because LST of 4 does not exist, it will give an error just like strings. Okay, it will give an index error. So don't try to do that. Now we can have negative indexing as well. Here also negative indexes go from -1 to minus the length of string. So -1, -2, -3, -4. -1 denotes the last element, then second last, and so on. So if I do LST of -1, -2, -3, -4, all the elements will be printed in reverse order now. So firstly we have true, then 0.1, then 2, and then A. Here also you cannot go to -5, that will give you an error. So this is how you can index elements in a list. And now list, unlike strings, are mutable in nature. They can change. So at the same memory location, if you want to change a particular element in a list at the same in the same list, you can do that. In the same list you can change elements. In the same list you can add elements, remove elements. You can do anything because lists are mutable. The strings are immutable, but lists are mutable. They can change. So let's see. Let's have the same list. Okay. Let's have the same list. Now in this list, let's say I want to change the element at the first index or 0th index, the first element, to instead of A I like to have B. I can do that. Now if I print list, the element will be changed. Okay, so it is at the same memory location. Whatever list was pointing to before, so I can prove that to you as well. So let's print the ID of list before, and let's print the ID of list after the change. It will be same at the same memory location. The list is present, the same variable is present, but its first element is now changed. Now let's look at slicing list in Python. How do we slice list in Python? Again, just like strings, the slicing works the exact same way. You can give starting point, stopping point, and step size. Step size is optional. It will by default is 1. The default of starting point is 0, and the default of stopping point is length of the list, and stopping point is not included. So all the concepts will work exactly as the same. So if I create a list containing, let's say, 5 elements, 1, 2, 3, 4, 5, and if I print list of let's say 0 to 3. So 0 to 3 means what? The starting point is 0 and stopping point is 3, and 3 is not included. So index number 0, 1 and 2 will be there. So it should create a list. And whenever you do slicing, another copy is created. It is not on the same list. The same list is untouched. Slicing always create another copy. For strings also it is the same, right? So it should contain 1, 2 and 3. Okay. And in the same way, if I forget to write the starting point, that's okay. The default value of starting point is 0 anyway. So here also the answer should be 1, 2 and 3. And if I print, let's say, a list of 3 colon. So it means the stopping point is not defined, but starting point is defined here. So I can write a comment here, and starting point is 3. Index number 3 contains what? 0, 1, 2, 3, 4. So 4 is the element present at index 3, and it will go till all, like it will take all the elements. So 4, 5 will be there. And what if I don't give the starting and stopping point, but I give the step size as 2? So it will take every second element. It will take every second element. So first element, and then third, and then fifth, and then so on. So its starting point will still be 0, but now it will take jumps of 2. So 1, and then 3, and then 5. And similarly, the standard way of reversing a string, you can have reversal of list as well, : -1. Here I'm taking step size as negative, so it will start from back and go all the way till front. So it will give us 5, 4, 3, 2 and 1. So if I run this, the expected outputs are actually same as what we expected. Okay. Cool. So this is how you can slice lists in Python, and again you can use negative indexes as well, like just as we did it in strings, you can use negative indexing while slicing as well. The same concept will be applicable here. Now let's say looping through a list. So there are, like, you can loop through a list using for loop and while loop both, but using for loop it is very easy because lists are iterable, and on any iterable if you want to iterate, for loop is better, because in for loop actually works on iterables only. So if I write for num in list, if I print num, that's all you need to do to iterate over all the elements of a list. It will give all its elements one by one. And if you have to do it using while loop, you can use indexing or accessing the first index, then second index and third index and so on. So let's say the index initially is 0, and so I'll write while I is less than the length of the list. While I is less than the length of list, because I can only access elements at index 0, 1, 2, 3 and 4 here. I cannot access 5. So if I is less than 5, which means 0, 1, 2, 3, 4, it will go inside, but when I becomes 5, it will come out. That's what I want. So I can just print a list of I. Okay. So this is another way of iterating over all the elements of a list. What is the mistake did I do here? Okay. I did the standard mistake. While loop ran in an infinite loop. Okay. I did not increment I. I forgot to increment I. So I plus equal to 1. And yeah, that's it. Okay. So all the elements are printed. So these are the two ways in which you can loop all the through all the elements of a list. Now let's look at some operations on list. First is mathematical operations. What are the mathematical operations possible on a list? Just like strings, you can add to list as well. Here also concatenation happens, which means all the elements in the first list and then all the elements in the second list will be coming in another list. Okay, so whenever you apply mathematical operations, another list is created. So if I print, let's say a list 1, 2, 3 plus the list 4, 5, they both will be combined, and another list will be created containing all the elements of the first list and then all the elements of the second list. Now just as strings, you can multiply a list with a number. So if I do 1, 2, 3 into 3, so 1, 2, 3, 1, 2, 3, 1, 2, 3 will be present 3 times. Again, the order is not important. You can multiply in the front as well. 3 into this is also allowed, and even you can do 3 into 1, 2, 3 into 2. So 1, 2, 3 will now be present 6 times. Okay, but generally no one does that. Ideally you should only do this way. This is more readable. Okay, so this is how you can multiply a list with an integer. You cannot multiply two lists. Okay, now we have membership operator. You can check that a particular element is present in a list or not. Let's say string B is present in a list containing, let's say, string A, string AB, and string C and string D. What should be the answer for this question? In this list there are 3 elements. One is the string AB, and one is the string C, and one is the string D. So string B is not present inside this list, so the answer should be false. And just like in, not in is the reverse of in, so that is another like membership operator. In and not in. Not in is reverse, it will give you true. So this is about membership operator. Now what else? We have length function we have already seen. So you can use the length function on any list and it will just give you how many elements are present inside that list. So if I add 1, 2, 3, 4, 5 elements in a list, the length will be 5. Cool. And we have mathematical operations which are min, max and sum. So let's look at that. So if I print the max of any list, let's say 34, 67 to 123, 12 and minus 90. So the maximum element will be printed. Now notice here all the elements should be comparable. If I have integers in a list, I cannot add a string, because you cannot compare a string to an integer. You cannot compare a string to an integer, but you can compare a string to a string. We know that, right? They get compared using lexicographical order. So if the string if the list contains all strings, then that is allowed. So let me show you that. Okay, let me show you that. If the list contains all strings, that is allowed. Let's say in a list I have a string A, then string B, then string C. That you can do. Let's say we want to find the minimum of this list. Then that is allowed because all the strings are comparable to each other. So you can have either all integers or all strings, but you cannot have an integer and a string both because they are not comparable. Okay, now let's look at the sum function. Again, you cannot add strings as such. Okay, you cannot apply the sum function on strings, but you can apply the sum function on integers. So in the sum function, if I give a list containing integers, let's say 1 2 3 4 5, 1 2 3 4 5, it will calculate the sum of all the elements and it will give me the sum. So min, max, sum, length, these are a few mathematical operations that are given on a list. Now how we can add elements to a list? I told you that lists are mutable and in the same memory location you can change an element that we have already seen. But how do we add more elements? We have seen that append function, extend function are there. So the list contains, let's say, 3 elements 1 2 3. If I do list dot append 4 and if I print list, 4 will be now also appended to the same list. Again, if you print the memory address, you will see that they are at the same memory location. Okay, and we have just added an element. And if I want to insert an element at a particular index, I can use the insert function. So again, let's say the list is 1 2 and 3, and if I do list dot insert, and let's say at the first index I want to insert 100, and if I again print list at the first index, now 100 will be inserted inside this list. Now what if I want to add multiple items? I can use the extend function. Inside the extend function I can give another list and all the elements in that list will be inserted in the first list at the end. So if the list contains elements 1 2 and 3, always remember that in extend function you have to give an iterable. Okay, you don't give an element, you give a list, and that list, all the elements in that list will be added in the previous list. In the insert function, if you give a list, that particular list will be added as an element at the end of that list. Okay, so I hope you remember that. So if I do this and if I print list, 4 and 5 will be added at the end of the list. What I was trying to say was, in the same piece of code, instead of extend, if I write append, what will happen? 4 comma 5, this list will be added as an element. This will be a single element that is added inside this list. So be aware of these two things. Okay, so these two are different. So this is how the append and extend function work in list. Now let's look at removing elements from a list. So we can delete elements from list as well. Again, lists are mutable, so everything can be done, everything you can think of. 1 2 3 4 5. Now if I do list dot pop function does what? It will remove the last element of the list. 1 2 3 4 will remain. And similarly, if I do pop at a particular location, if I do pop at 1, what will happen? Element at index 1 will be removed. In the pop function, if I give an index, element at that particular index will be removed. So this is how the pop function works. You can either give it directly or you can give it an index. Now let's look at remove function. Pop function works on index, but remove function works on value. So I can give any value and that particular value will be removed. So if I say lst.remove, so let us take a better example. Let's say a list contains A, B, C and the string D. Now suppose I don't know where B is present, but I want to remove B. I cannot use the pop function because pop function requires an index. But remove function, in remove function I can directly give the element and that particular element will be removed from the list. So this is how the remove function works. And if you have the index, actually there is another way you can delete elements if you have the index somehow. So what is the way? You can use the del keyword. Okay, we have seen we can use the del keyword on an entire object, an entire memory location wipes out, right? And you can actually use it on a particular index as well. So if I write del of list 1, so this also does the same thing. It will delete the whatever is present at the memory address of list of 1. List of 1 means index 1. So at index 1 B is present, so that element will be deleted. So if I print the list again,
that element will be deleted. So this is also how it works. And the beautiful thing about del keyword is I can give any like I can give a slice as well. So what I'm trying to say is I can, like, let's say 1 2 3 if I write it this way. So all the entire slice from 1 to 3, again this is slicing, so 3 is not included. So like basically from index 1 to index 2, B and C both will be removed in this case if I write it this way. So delete list 1 to 3. So B and C both are removed. So I can give it a slice as well. And what if I write the delete keyword on the entire list? Instead of this, I write the delete key. I use the delete keyword on the entire list. This deletes the entire memory location where this list is present, including the variable. Nothing is left. Right now, after deleting, LST is not even defined. So remember that after deleting a variable using del keyword, it does not exist. You cannot use it again. But here you can, because here you are giving a slice or an element. And if you want to just clear all the elements, and if you want to keep the variable and the memory location, you can use the clear function. You can use the clear function 1 2 3 4. Let's say it contains 4 elements, and if I use lst.clear, it will clear the list, and in still the same memory location, at the same memory location this variable will be pointing, but it will not have any elements, that's all. So it will just be an empty list now. It will just become an empty list. So these are all the methods of adding and removing elements from a list. Okay, now let's look at searching and counting methods in a list. So just like string, we can search that a particular element is present in a list or not, at what index it is present, and we can count how many times a particular element is present as well. So let's create a list containing elements, let's say A, then 2, then C, then 4.0, and then 5 plus 0 j. Okay, some complex number as well. So in this list, if I print let's say the index of index function is used to find the index of any element. If I find the index of 2, it will give me 1 because 2 is present at index 1. If I find the index of 4, it will give me 3 because 4 is present at index 3. If I try to find the index of 4.1, it will give me an error because 4.1 is not present inside this list. So this is how the index function works. You can give it a string, C is present at index 2. So this is how you can find the index. Now next is count, how many times a particular element is present. So let's take another list. Let's just make C twice inside this list. And if I just count how many times C is present here, it will be present 2 times, and hence the count is given as 2. So this is how you can find the index of a particular element, search, and then count it using the count function, index and count function. Now let's look at sorting and reversing a list. So you can sort a list in place using the sort function that is given for list. So if I have 1, 4, 3, 2, 5, then 4, 6, and then 2 again, let's say. And if I do list.sort, it will sort all the elements in place, which means at the same memory location now list will be sorted. This is the sort function for you. Sort. Okay. Sorry, you have to print list. Okay. So it prints the list in sorted order, and the original list is now gone. So if you want to preserve the original list as well, either you create a copy of it or you can use the sorted function. Before that, let us see reverse as well. So we have seen inside the sort function, if I give reverse is equal to true, it sorts it in the reverse order. Okay. And if you want to make another copy, and if you don't want to change the original list, you can use the sorted function for that. So for sorted function, the syntax is slightly different. So if I have create another list, sorted list, let's say sorted list, and if I give it to sorted function, this is how you do that. It's not list dot. Whenever you use a collection dot, it means you are doing something in place. Okay, remember that way. And if I print the sorted list now, it will print the list in sorted way, and here the list itself is not changed. If you print the list itself, that is still the same initial list. So that is how you sort a list using the sort function or the sorted function. And if you want to reverse a list, you can use the dot reverse function. Again, that works in place. So if I take the same list and if I do list dot reverse, and here if I print the list again it is in place. If you have to do it out of place, which means if you don't want to change the original list, you can use slicing : -1. that we have already seen. That will create another copy and you can take it in some other list if you want. So this is how sorting and reversing a list works. Now let's look at nested list. So in Python you can create a list inside a list. So you can create matrices basically. So let's say I create a matrix 1 2 3 and then another list is containing 4 5 6, then another list is containing 7 8 9. Okay, so if I print the matrix here, it will be a list of list, and if you print the length of matrix, it will just tell me how many elements are there in matrix. So there are 3 lists present inside the matrix. There are 3 lists present inside this list, so 3 will be printed. And similarly, if I print the length of matrix, any element, let's say matrix of 0, then that will also be 3 because 3 elements are present inside matrix of 0. So this is how it works. You can create nested list, any number, like any depth you want, you can do that. So this is how it works. And again, like let's take another example. Let's say there is a list containing elements 1 and 2, and if I append another list to it, append function element inserts a single element. So if I append another list, that list will be inserted as an element inside the original list. So if I append 3 4, then this list will be inserted. So if I print lst now, it will contain 3 elements, 1 2 and the list containing 3 and 4. Now what you can do is, let's say if I do list lst dot append 5, then okay, sorry, yeah, now let's print the list again. Then 5 will be added at the end of this list as well. And if you do lst of let's say this particular list is present at which index, 0 1 2. So if I do lst2, because that is another list, dot append let's say 6, then inside this 3 4 wala list 6 will be appended. So like pretty basic, all the lists are mutable, a list inside a list and everything, because they are all present in different memory locations. We have seen memory management. Okay, if I print this list now, it will be 1 2 3 4 6 and 5 here. Okay, so this is how like nested lists work. Now let us look at shallow and deep copy. Why do we need this? Because if you have list inside a list, that particular memory location will be copied as it is, and you will not have like a deep copy. Like, yeah, so we already know the concept. Let's take a look at that. Let's say there is a list containing elements 1 2 and 3, and if I do the first and the most basic way of doing a copy is this does not create a copy. This is just a pointer assignment or a address assignment. B and A are pointing to the same memory location, they are pointing to the same list. So if I do b dot append 4, essentially A and B both will change. So if I print A now and if I print B now, both will be pointing to the same memory location, the same list will be printed 1 2 3 4. So how do we create a copy? You can use the copy function. So you can say that B is equal to A dot copy. So this will create a copy, but again this will create a shallow copy, we know that. But if a list does not contain another list inside it, you don't need to worry about shallow copy. This is perfectly fine. If I do b dot append 4, that is okay. If I print A will not change because we created a copy, and only B will change. So everything works good. Another way of creating copy is using slicing. I can just do slicing, and slicing creates a copy, I know that. And slicing also creates a shallow copy. So this is also shallow copy, but again this also works fine. Another way of creating copy is using the copy library. So from copy library, if I use the copy function, just the copy function, not the deep copy function, then it will also work exactly the same. So here if I do copy.copy of A, this also works at the same way. Here also a shallow copy will be created, but everything works fine. So on a list which does not contain another list, you don't need to worry about it, and shallow copy will work fine and everything is good. Now let's look at the concept of deep copy. So let us say we have a list A containing another list. So 1 and then 2 3 and then 4 5. Okay. So if I write B is equal to A dot copy, and I can use any of the functions, like for shallow copy you can use any of this, A dot copy or slicing or copy dot copy, any one of these three, the same thing will happen. What will happen? So when you create this copy, what will happen? If I do B of 1 means this list 2 3 dot append, let's say 6, and if you print A and if you print B, both will change. The reason is this list inside the list has the same memory address and the memory address was copied, right? We have seen this concept. But in the same concept, if I just wrote b dot append, let's say 7, then this 7 will be appended only to b. This 7 will be appended only to b, right? Because it is another list. It is actually another list, but the list inside the list had the same copy. We have seen that diagram, right? According to the diagram, everything works out. And this is the problem of shallow copy. This is what shallow copy means. And this, like using any of the three ways, this will happen. Like using a dot copy. And if you want to watch it, like you can watch the lecture again. There I have discussed in detail why this happens in memory management. So even if I use slicing, the same thing happens. Even if I use copy dot copy, same thing happens. Let me show you. Same thing happens. Okay. 2, 3, 6 and then 4, 5, 7. So 7 is appended only in B, but the 6 was appended in both of them. Why did this happen? Because the memory location was actually copied and the at first index both are pointing to the same list, and that's why this happened. I can prove it to you that prove that to you as well. So let me just write it this way, the easiest way to make a shallow copy, and let me prove it to you. So what I'll try to do is I'll try to print the memory address of a of 1 and b of 1. That should prove it, right? ID of a of 1 and ID of b of 1. So the address was copied and hence they are both pointing to the same memory location. That was the issue, right? But now let's create a deep copy. In the same example, if I use copy dot deep copy instead, so I have already imported copy library, that's why I don't have to do it again and again. But if you're using it for the first time, you have to run the command import copy, otherwise it will not work. Okay, so now instead of this, if I do a deep copy dot deep copy of a, so this is like creating a deep copy. Now a new copy will be created. They will not be pointing to the same memory location. If I print a and b, a is untouched now. A is untouched now. And to prove this point, now if I print the ID or the address of a of 1 and b of 1, it will be a different memory address. It just creates another copy and the memory addresses are different. Okay, so this is how shallow copy and deep copy works. We have seen an actual implementation hands-on as well. Okay, now let's look at list comprehension. So we can actually create list. It's a most powerful tool, like to create list. So we can create list just by inside the list we can write many things. So we can write a for inside a list, inside the square brackets itself. So if I write x for x in range 1 to 5, this will create a list containing elements 1, 2, 3 and 4, because range 5 gives the elements 1, 2, 3, 4 and all these values are taken by x, and inside the list I am placing x only. So the same logic follows. This is how you can create lists. Okay, and here I just displayed the list. I didn't store it or print it, but yeah, I just displayed it as it is. And same like we have seen examples in class, like we created a list called squares, which contained a list of squares of numbers between 0 and 4. So very simple. Here you will write x square for x in range 0 to or range 5, because 0 to 4, like all the squares will be present. So I can print squares after that, and this is the list containing the squares of numbers between 0 and 4, 0, 1, 2, 3, 4 squares. And you can write an if condition as well. So let's say I only want to write the squares of even numbers, so between 1 and 0 and 10, let's say. So I can write a condition if x modulo 2 is equal to 0. So only even squares will be present now. Okay, so I can name it even squares. So it's one of the most powerful tools, right? List comprehension. We have seen this, and we can. It's not that you have to use x here. You can skip using x as well. We created something called labels. So every alternate number is even or odd. So I will just say it is even for x in range 10 if x modulo 2 is 0. Else I can say it will be odd. Okay. Okay, sorry, the syntax was slightly wrong. You will have this when you are writing if else. Remember that the for loop goes after the else. Okay, don't forget this. even if x modulo 2 is 0, else odd for x in range 10. Yeah, so every alternate number thing will be even odd, even odd, even odd, even odd, and like that. So this is how you can use list comprehension using if else, just if, or not using if else at all. These are the three ways. And using this we can actually you can use it on nested lists as well. So if you have a matrix and if you want to flatten it out, again it's a pretty basic code which can be asked in your interviews as well. So if you want to flatten a list, if they are taking a hardcore like Python interview, they can definitely ask you this question. So if you want to flatten a list, so you can just take the item and you can write two for loops for row in matrix and for item in row. So this is how you can flatten it. If you print the flattened list, it will be just the one flattened list of all the elements inside the matrix. Okay, so this is how list comprehensions work. Now let's move to the practice exercises that I gave you in class. I gave you 6 problems and you should try all of them on your own first. If you're not able to see, we will see 3 problems in class and 3 will still be in homework. When I give you the notebook at the end of the day, you will have the solutions to the homework problems as well. They are very simple, okay? First, add all even numbers from 1 to 100 into a list. All even numbers from 1 to 100 into a list. So there are a few ways to do this. First is let's use a for loop. So let's create a list and if I can I can write a for loop from 1 to 100. So the range function will go from 1 to 101 because it should start at 1 and it should stop at 100. Stopping point is not included. So I will go from 1 to 101 and I will add it to the list and I will add I to the list. I will append I to the list only if it is an even number. So I will check that if I modulo 2 is 0, which means if I is an even number, then only add it to the list. List.append I. So this is one way of doing this, right? If I print the list, it will contain all the even numbers from 1 to 100. Another way of doing this is you can actually write this entire piece of code using a list comprehension. We know that. So what we can do is I can just directly say create a list like this. So I will just add the number I for I in range 1 to 101 only if I modulo 2 is 0. That's all. This is another way of doing it. So that is why list comprehensions are so powerful, right? They can make your code look pretty easy and they can you can have the entire for loop written in a single line. So this is how you solve the first code. Now second and third will be homework. Second is remove all negative numbers from a list. Very simple. You can use the remove function or you can create another list and anything you want. Find the second largest number in a list. There are 2 ways to do this. One is you can sort the list and get the second last number, or you can sort it in descending order and get the second number, or you can take 2 variables. I'll not give you much of hint. You can try on your own. Okay, if you don't want to sort it, then also you can do it. Cool. Let's move to the fourth problem. That is also homework. Given a list of numbers, separate them into 2 lists, one of even numbers and one for odd numbers. Again, the challenging part for this will be you can use list comprehension to do that, or you can use a for loop, but try doing it using list comprehensions. Now let's look at the fifth problem. Write a program to remove duplicates from a list without using set. Why is it mentioned without using set? This thing we will see in set lecture, because sets cannot contain duplicates. So you can remove all the duplicates from a list in a single line of code using set. But if you're not allowed to use sets, how will you do that? So you will have to use a loop. And if the element is already present in the list, you will not add it in the other list. So let's see. Let's take a list 1 2 1 2 2 1 3 2 3 1 4 3 4 1 2 1 3. It contains a lot of elements and most of them are duplicates. Okay, so all the unique elements here are 1 2 3 and 4. Now let's create another list which does not contain duplicates. Unique list, and it is an empty list initially. So what we can do is I can iterate over all the elements inside this list, and I will add it in the unique list only if it is not already present, and I can use the membership operator to do that. So what I'll do is, for element inside the list, I want to add this element in the unique list. What I want to do is I want to do this unique list dot append element. But this will not solve my problem because this will just add all the elements. I want to add this only if this element is not already present. So what I'll do is if element is not in unique list already, if the element is not in unique list already, then only append it to the unique list, otherwise don't add it. Make sense? So this will now contain all the unique elements. So if I print the unique list now, it will only contain the elements 1, 2, 3 and 4. So this is how we can do it, and later when we see DSA, we will see that the time complexity of this solution is not very good. It is n square, but we can do it better like using some other way, using sets obviously. So yeah, like there are various ways to solve this problem, but we are not worried about the time complexity right now. We wanted to solve the problem and we solved it. Now next problem, very interesting problem. Rotate a list to the k to the left by k positions. So let's think about it. Like let's say this question is given to you in interviews. What will you do? Let's say the list is 1, 2, 3, 4, 5, 6 and 7, and the list contains these elements and k is given as 2. So we have to rotate the list. Rotate means all the elements will be preserved. So if you rotate this list to the left by one position, what will happen? 2 will come to the left. So 2 will come as the first element, then 3, then 4, then 5, then 6, then 7, and 1 will roll back to the last position like this. So this is first rotation. This is the first left rotation. And similarly the second left rotation will look like this 2 will all of these will shift to left, and then 2 will go at the end. This is the second left rotation. Let's comment it. This is just for us. Okay, cool. So how will this work? How do we do this? Think about it. Essentially what we are doing is, for any value of k, what are we doing? If k is 2, notice that we are taking elements from this value. If k is 2, we are taking elements from kth index. We are taking all elements starting at kth index. Right? We are taking all the elements starting at kth index. Then at the end we are appending all the elements till the kth index. That's all. Right? That's all we are doing. We are starting at the kth index. We are taking all the elements starting at kth index, and then after that we are adding all the elements before the kth index. So if you take examples, the problem becomes very simple, and I'll give you a beautiful solution to do this. Let's say your list contains these elements. My claim is, for any value of k, let's say k is 2, if you want to rotate it, you can just let's say you want to keep it in another variable, rotated list. The answer is just you take all the elements starting at kth index, then at the end you add all the elements till the kth index. That's all. That's what you're doing if you want to do k elements left, rotation of k elements to the left. Now what if you want to do it to the right? That is also a very simple problem. You can try it as homework, and here I can print the rotated list. That's all. Here the answer is 3, 4, 5, 6, 7, 1, 2. Okay, but again there is an issue in this code that this will only work if k is less than the size of the list, because if k is greater than the size of the list, then this slicing will not work. What to do in that case I will not discuss now, because in number theory we will see how to use modulus operator in a better way. But again, consider that this as homework. I'll add 2 homework problems in this problem. Homework problem 6.1 6a is rotate this list to k positions. Rotate this list by k positions to the right. First is to the right. Okay, and the second homework problem here should be what if k is you have to think about it. What if k is greater than or equal to, or just greater than the length of the list? What will happen in that case, and how will you solve this problem? So think about these 2 problems, and again consider them as homework. Okay, these are 2 homework problems for you in problem number 6 as well. Cool. So this was all a demo about list in Python, And yeah, thanks for watching the video, and let's meet in the next lecture. Bye bye.